Hey everyone, and welcome to today's deep dive. I am super excited to get into this one with you because it starts with a pretty mind-bending premise.
Yeah, it really is. It's one of those things that sounds like sci-fi, but is happening right now.
Exactly. So picture this. Major tech companies are currently building these supercomputers the size of small cities.
Oh, easily. Like gigawatt server farms.
Yeah, just endless racks of GPUs, massive infrastructure overhauls. But behind closed doors, there is this quiet, very real panic setting in.
A massive panic.
Because they have the hardware, they have the power grid, but they are completely running out of the most crucial ingredient. They're like running out of the internet.
Right. It is the ultimate bottleneck. And, for years, the AI industry operated in what we call a compute-bound regime.
Meaning we just needed more chips.
Exactly. The logic was super simple. If you want a smarter model, just buy more processors. But the hardware has finally caught up.
To the limits of human output, basically. Yeah, we've entered this new era, the data-bound regime. The processors are hungry, but the high-quality organic text books, articles, websites written by actual humans, it's falling drastically short of what scaling demands.
Which brings us to the core of what we're looking at today. We have this fascinating state-of-the-art research paper, and it's titled Generating Pre-Training Tokens from Organic Data for Data-Bound Scaling.
It's a bit of a mouthful, but a really important paper.
For sure. And our mission today is to figure out how these researchers are trying to break through this dreaded data wall. Like, if you can't scrape another billion web pages because they literally haven't been written yet, how do you squeeze more intelligence out of the data you already have?
Right, because you can't magically make more human history appear.
Okay, let's unpack this. What exactly is the scale of the problem here?
Well, the paper quotes a sentiment that's attributed to Ilya Sutskever. He basically observed, we've achieved peak data and there'll be no more.
Wow. Peak data.
Yeah. To train the next frontier of these foundational models, the scaling laws dictate that we need an order of magnitude more data than currently exists in the whole public organic corpus.
Wait, so like 10 times more human text than the entire accessible internet?
Roughly, yeah. That's the terrifying math they're looking at.
So my obvious first instinct, if I'm a lab and I'm running out of fresh data, is just to, I don't know, run the data I do have through the machine again.
Right.
Like run multiple epochs over the same organic corpus.
Which makes sense intuitively. It's like
reading the exact same book 10 times to prepare for an exam.
Exactly. But eventually you stop learning new things.
Yeah.
And the researchers confirm this is exactly what happens to LLMs.
It just stops working.
Yeah, it fails almost instantly. When you look at the loss curves for models trained on repeated passes of the exact same text, you see these diminishing returns right away. The curve just flatlines.
Because it's just memorizing at that point.
Right. The model isn't generalizing or extracting deeper concepts. It's just defaulting to rote memorization after a few epochs.
Okay, so symbol repetition is out. But, hold on. We have these massive, super capable AI models right now. If we're out of human-written data, why don't we just use AI to write infinite new data?
Ah, the synthetic data dream.
Right. Just spin up a cluster and have a current model hallucinate a billion new Wikipedia articles. Problem solved.
The industry definitely tried that, but unconstrained synthetic data is incredibly dangerous. The paper highlights this heavily.
Dangerous how? Like, it just makes things up?
Worse, it causes something called model collapse. The researchers actually refer to it as a tail of tails.
Tail of tails. Okay, let's visualize that tail distribution. Because if you think about it, it's like an AI writing a cookbook based entirely on human recipe.
That's a great way to think about it.
Right, so it scans the data and notices salt and pepper are in almost everything. So the next generation of the cookbook puts salt and pepper in literally every single recipe.
Right, it just amplifies the most common things.
Yeah, but then it completely forgets that, like, saffron or truffles even exist. The rare, nuanced edges of human culture just get erased.
That is the perfect analogy. The math behind these models inherently favors the most probable average outputs.
Yeah.
Human data has a long, rich tail of highly specific, rare information. Your saffron and truffles.
And the AI just steamrolls right over it.
Exactly. When an AI generates unconstrained data, it strips away those rare nuances. So successive training on that output means the model just distills its own limited knowledge.
It collapses into a narrow echo chamber.
Right. An echo chamber of its own high probability biases. It doesn't learn anything new about the real world.
So we are caught in this trap. Simply repeating the real data causes stagnation, right?
Yep. flatlines the learning.
And hallucinating fake data causes model collapse, so you're just left with this gray smudge of information.
Which is exactly why researchers had to invent a completely new way to process information. And that leads us to SYNPRO.
SYNPRO. Okay, what is that?
It's a synthetic data generation framework. But it operates under this strict, non-negotiable philosophy: do not invent new facts.
Oh, interesting. So no hallucinating new textbooks.
Right. Instead of making up new concepts, SYNPRO is designed to help the LLM more thoroughly learn from the limited organic data we already have.
Okay, let me try another analogy for you. Think of the organic data, the real internet, like a dense textbook.
Okay, I'm with you.
Simple repetition is just sitting in a room, rereading the chapters until your eyes glaze over. But SYNPRO is like bringing in a world-class tutor, right?
I like where this is going.
And the tutor takes that exact same textbook and does two distinct things. First, they take the confusing paragraphs and explain them using entirely different words.
Yeah.
Second, they take the chapters and actively turn them into flashcards, debate prompts, and quizzes. You're using the same source material, but you're learning way more.
That is spot on. And you actually just described the two operations SYNPRO uses:
Oh, nice. What do they call them?
rephrasing and reformat. Let's look at rephrasing first. The goal here is to introduce lexical and syntactic diversity.
Meaning changing the vocabulary and grammar.
Exactly. It alters the word choice, restructures sentences, changes clause ordering. But, and this is crucial, it rigidly preserves the core semantics of the original text.
So it's separating the knowledge from the specific words used to express it.
You got it. It forces the pre-training model to map the exact same underlying fact to a completely new linguistic structure.
That makes total sense. And the second one, reformat.
That one pushes it even further. It converts the source content into task-oriented forms. So it takes a standard Wikipedia article and turns it into a comparative analysis or maybe knowledge highlights.
Or like a structured reasoning trace.
Exactly. Or a dense series of question and answer pairs.
So it's forcing active recall rather than passive consumption. But here is the massive red flag for me.
Okay, let's hear it.
If this YMPRO tutor is essentially an AI model itself, churning out all these flashcards across petabytes of data, how do we ensure the tutor doesn't just start making things up?
The drift problem.
Yeah. Or just feeding the student endless redundant questions that it already knows.
Well, that requires a brilliant reward system.
Here's where it gets really interesting. How do they actually control this thing?
They use reinforcement learning, or RL, to train SYNPR before it ever outputs pre-training tokens. And they use 3 very specific rewards.
Okay, let's break down these rewards because they aren't just like filtering bad data at the end, right? They're actively shaping the model.
Right. They use proximal policy optimization PPO. Every time the generator makes text, it's evaluated against 3 criteria.
And it gets a score.
Exactly. A scalar reward that updates its internal weights. Reward number 1 is quality.
Quality meaning what exactly?
They use a tool called DataMan to score the output for things like semantic density and grammatical diversity. It basically stops the AI from generating gibberish.
Oh, I see. So if it spits out structurally broken sentences, it gets a low reward and learns to stop doing that.
Exactly. It ensures coherent, well-formed text.
But clear English doesn't mean factual English. I could write a beautiful sentence about the moon being made of cheese. How are they keeping it faithful to the source?
That's reward number 2, faithfulness. And this is the most critical guardrail against that modern collapse we talked about.
Okay, how does it measure faithfulness?
For the rephrasing operation, it uses BERT score to check semantic similarity.
Right.
But for the reformat operation, they actually use an LLM as a judge. Specifically, they use Qwen3 1.7b to ensure the output is strictly grounded in the source.
Wait, hold on. They are using a 1.7 billion parameter model to judge the faithfulness of a massive pipeline?
Yeah, I know. It sounds a little counterintuitive.
I mean, isn't that like asking a middle schooler to grade a graduate-level thesis? How does a relatively tiny model reliably police hallucinations at that scale?
It's a really valid question. But you have to distinguish between the complexity of generating reasoning versus the complexity of verifying it.
Okay, fair point.
Judging faithfulness here is a highly constrained, narrow classification task. You give the smaller model the source paragraph and the output, and you ask one binary question.
Did it make anything up?
Exactly. Does the output contain any info not present in the source? A 1.7b model is highly capable of running that specific check efficiently.
So it doesn't need to understand quantum physics, it just needs to be an incredibly strict librarian.
Yes. And you need it to be efficient. because you have to run this reward function millions of times during PPO.
Yeah.
And the impact is staggering, by the way.
Give me the numbers.
The paper notes that without this faithfulness reward, a base model produced unfaithful answers 57% of the time.
Over half the data was corrupted. Wow.
But with SYNPRO and the faithfulness reward, it achieves a 96.1% faithfulness rate.
That is a massive difference.
It's the difference between learning reality and learning a fantasy.
Okay, so we have quality to keep it readable and facialness to keep it true. What's the third reward?
The third reward is data influence, or model awareness.
Model awareness, meaning it knows what the student model knows.
Exactly. Imagine a teacher who only tests you on the stuff you keep getting wrong.
Right, skipping the stuff I've already memorized. Like if I'm learning a coding language and the tutorial just keeps making me write, "Hello, world," I'm going to stop learning.
Exactly. A smart platform sees you struggling with async functions and gives you practice problems exclusively on that. This reward does that for the LLM.
That's brilliant. So it steers the generator toward content the current pre-training model has yet to absorb.
Yes, it calculates the loss reduction. As the model naturally plateaus on certain topics, SYNPRO continuously updates to target its specific blind spots.
So the training data set is constantly shape-shifting. It's a localized adversarial teaching mechanism.
Beautifully put.
All right, knowing the theory is great, but does it actually work? I want to see the proof. What was the experimental setup to test this?
They set up a highly constrained environment. They pre-trained 2 models from scratch, a 400 million parameter model and a 1.1 billion parameter model.
Okay.
But they restricted the organic data pool to only 10% their optimal data.
So they intentionally starved them to simulate hitting the data wall.
Exactly. And then they unleashed SYNPRO on that 10% to see if it could bridge the gap.
And what were the astonishing results?
Well, compared to simple repetition, SYNPRO unlocked 5.2 times the effective tokens.
5 times the functional intelligence just by rephrasing and reformatting.
Yeah, but what's fascinating here is what happened at the 1.1 billion scale.
Tell me.
They created an oracle model trained on the equivalent amount of completely unique, brand new data.
The ideal scenario.
Right. And SYNPRO, using only a fraction of the data, but running it through this intelligent RL framework, actually surpassed the oracle model.
Wait, really? So a model looking at a small amount of data from multiple angles learned more than a model that just passively consumed a massive amount of unique data.
That's exactly what the data shows. It completely upends the more is always better scaling law.
Let's ground this with some specific examples from the source, because seeing what the AI was doing is super helpful. Let's talk about that ACT anxiety example.
Right, the rephrasing example. So the source text was a highly specific piece on managing test anxiety. It detailed cognitive rehearsal and specifically mentioned using diaphragmatic breathing to stimulate the vagus nerve.
And it cited a methodology from an organization called HeartMath, right?
Yes, very dense, fact-rich medical advice. When they ran that through a standard base model for rephrasing, the output was painfully generic.
I think the AI basically said, just take a deep breath and engage in conversations. It completely stripped out the vagus nerve in the HeartMath citation.
Exactly. It smoothed over the tail distribution. It lost the nuance.
That's why SYNPRO handled it differently.
Beautifully. Constrained by that faithfulness reward, it restructured the syntax to be more engaging, but it explicitly retained the neurobiological mechanics.
So it kept the vagus nerve and the specific technique, making it fact-rich without losing the core advice.
Precisely.
Now, what about the reformat example? Because this shows the data influence reward in action.
Right. The virtual reality article, it discussed design principles like visual saturation and mentioned Fitts law. But it also had a section on how immersive VR can induce genuine psychological trauma.
So in the early stages, what did the model do with that?
In Policy 0, the early stage, the generator just asks surface-level questions. What design principle is discussed? Answer: saturation.
Flashcards for beginners.
Right. But as the data influence reward kicked in, the model realized the student already knew Fitts' law. So the updated generator started asking completely different questions.
It shifted to the complex stuff.
Exactly. It started asking about the ethics of traumatic VR experiences and psychological stress. It realized it needed deeper learning.
The generator evolved alongside the student model. That's incredible.
It constantly peeled back layers of the exact same organic paragraph.
So what does this all mean? If I'm synthesizing this journey, the core insight is that the future of AI isn't just about scraping more of the internet, is it?
No, not at all. Organic data is not exhausted. it is significantly underutilized.
Right. It's about learning more efficiently from what we already have. Grounding synthetic data with that faithfulness reward, combined with targeted teaching, that creates a sustainable path forward.
It shatters the data wall by making the models dramatically better students. And, if we pull back for a second, it leaves us with a pretty provocative final thought.
Well, I'm ready. Let's hear it.
If a multi-billion parameter AI model is only absorbing a fraction of the value from a text the first time it reads it, requiring constant reformatting and perspective shifts to truly internalize the knowledge, what does that say about how we humans consume information?
Wow. We just read an article once and assume we get it.
Exactly. The next time you feel like you aren't learning something new, maybe the problem isn't the material. Maybe you just haven't reformatted it yet.
That is definitely something to mull over. We leave so much insight on the table. Thank you all for joining us on this deep dive. We'll catch you on the next one.